Purple's my favorite color, but the Joker themed pinstripes ain't it, people. I'm on day 2 of week 8. So how is it that my plants, which clearly have a genetic propensity to go purple, have stems in week 8 that are so vibrant green? I've been pushing 1450 PPFD at the top, 650 through the inside, and 500 down below almost this whole run. So it's definitely not just that any light is too much light, because not a red stem in sight. The biggest takeaway I want people to have from my videos will always be that understanding no input or decision you choose to make in your garden happen in an isolated vacuum. Adjusting your VPD has consequences on water uptake, which changes nutrient delivery, cooling capabilities, and transpiration, which changes photosynthetic capabilities, which changes nutrient and water demand, which changes our VPD requirements. See what I'm getting at here? We've got a spinning wheel. It's perfectly balanced with weights on the outside of the rim. If I move or change those weights without adjusting the rest to rebalance, we're going to notice that that wheel starts to wobble. It might seem trivial or go unnoticed at first, but every time that wheel rotates, the inertia of the imbalance is going to throw that wobble a little further out. Because of the nature of the wheel, we tend to only notice the wobble at its furthest point of correction, which makes us overcompensate our correction, adding further imbalances to the spin. That wobble becomes aggressively exponential with every turn until it wobbles so violently the whole system rips itself apart. Red stems at any stage, quite frankly, is the first barely noticeable wobble. You're calling it genetics or just pushing through it because it's just something that happens. You're ignoring a very real signal that you've got a wobble in your wheel. As you already know, those red stripes are anthocyanins, a pigment your plant is actively building up through the phenylpropanoid pathway because they got a pretty big job to do. They absorb excess light, buffer reactive oxygen species when electron flow starts backing up, and protect tissue while the plant is adjusting to whatever part of the system is creating that pressure. Have a look at where it's showing up first. The stems and petioles are exposed tissue sitting right beside the vascular system carrying water, minerals, and carbon between sources and sink. So when something upstream or downstream starts restricting that flow, this is where the imbalance starts to become visible. It's not costing them nothing either. There's a photosynthetic ceiling that determines a finite amount of carbon they can capture in a day. To make those purple stripes, it's got to pull from that carbon, spend ATP, use NADPH to drive that chemistry, build the enzymes that run it, and transport and store those pigments in the tissue. That's all carbon energy that now can't be used anywhere else. So even if you think the red striping is minor, the plants have now already allocated resources to deal with whatever imbalance made that measure necessary. Too much light for current capacity, electron transport gets backed up, ROS pressure rises, anthocyanin response. Root zone EC climbs, water uptake gets harder, stomatal conductance drops, CO2 assimilation falls while photon pressure stays high, anthocyanin response. VPD gets pushed too hard, plant can't maintain water status, stomata close, carbon fixation drops, excess excitation has nowhere productive to go, anthocyanin response. Sink demand or nutrient delivery gets bottlenecked, sugars accumulate upstream, and metabolism slows. Photosynthetic feedback limitation increases. Anthocyanin. We've all got the numbers memorized, but this VPD, this PPFD, this EC, at this much CO2, keep your temperature here. You can have every single one of those numbers sitting exactly where dialed in should be. Here we are, and something in the plant is already telling us that something in that combination is wrong. Move one piece and everything downstream of it moves with it too. Push a higher VPD and now the plant has to move more water to maintain its water status. That changes root uptake, nutrient delivery, stomatal conductance, and leaf cooling. If the roots can't supply that increased demand, stomata start closing. Now, less CO2 is getting into the leaf, carbon fixation slows, the same amount of light becomes harder to process, leaf temperature starts climbing, water demand changes again, and the EC in your media starts moving because uptake and irrigation are no longer matching the way they were before. The fucked up part is if you keep an eye on the controller through that entire cascade, every individual number will still look right. VPD right, PPFD right, CO2 right, input EC right. Somewhere in that plant, the relationship between them has drifted far enough that the plants have already started spending energy trying to keep the whole thing together. And you can see that energy in the stems. So how can we tell if the system's actually imbalanced? Well, that's the million-dollar question, isn't it? We've got to stop chasing metrics we've memorized and focus on whether the relationship between those numbers stays stable throughout the day and throughout the run. Your input EC stays the same, but your root zone EC starts climbing. Something's changed. The same environment suddenly giving me a smaller dryback. Something's changed. Leaf temperature getting closer to air temperature. Something's definitely changed. Irrigation time shifting, water uptake slow, or the plant just needs more correction to hold the same target. Something changed. Those are the little wobbles I want you to catch before the plant has to start spending energy on correction. And that brings us right back to these green stems. Green stems this late in flower under this much light on a plant that very obviously knows how to make anthocyanin tells me the system stayed balanced enough that they haven't need to allocate resources into that response. I don't give a shit about green stems aesthetically. I use them as another piece of information that the relationship between light, water, carbon, nutrient up, the environment are all still working together in a way that's most optimal for this plant. If you like these kind of explanations, make sure you go hit that like and subscribe button and let me know in the comments what you want to hear next.